Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about dependent and independent vectors. In order to understand this class, in our last classes, we already discussed about the concept of spanning a vector space and what is meant by subspace and vector space. These concepts we already discussed in our previous classes. Please watch those classes and come back here because we are going to use that concept here. The link for the playlist is provided in the description below. Coming to today's class, let's take this vector 2, 1, minus 5. This is a vector in a three-dimensional coordinate system. So what's the space that we are able to span using this vector 2, 1, minus 5? We can span a line in a three-dimensional coordinate system. See, this is the example. We can span a line in a three-dimensional coordinate system. Because 2, 1, minus 5 moves in this direction. By multiplying with some scalar, we can move in the same direction. We can move front or we can move back. Like that, this is how we are going to span. Means we are able to reach any point on this line by using this vector. That is what spanning means. So this we call it as independent vector. So why it is independent, in a minute you are going to understand. Let's take one more example, 2, 1, minus 5 and minus 1, 2, 8. These are the two vectors that are moving in two different directions. With these two vectors, we are able to span a plane in a three-dimensional coordinate system. Means we can cover an entire plane in a three-dimensional coordinate system with these two vectors. So these two are independent vectors. Now coming to the next point, 2, 1, minus 5, 4, 2, minus 10. They have given you two vectors, but using these two vectors, we are not able to span a plane in a three-dimensional coordinate system. Why we are not able to span? Let's try to understand. 2, 1, minus 5, it is moving in one direction. But look at it. By multiplying 2, 1, minus 5 with 2, you are going to get 4, 2, minus 10. Means this vector is also moving in the same direction. Means using these two vectors, we are able to span a line in a three-dimensional coordinate system, not a plane in a three-dimensional coordinate system. If you want to span a plane in a three-dimensional coordinate system, you must have two vectors that moves in two different directions. Then only we can span a plane in a three-dimensional coordinate system. Why we are able to span a plane in a three-dimensional coordinate system? That point we clearly explained in our previous classes. So that's why this vector 4, 2, minus 10 is dependent on this. By multiplying means by applying some vector operations on this vector, we are able to get this vector. Means this vector is on the same line. So this is dependent vector and this is independent vector. Some people say that we can write it as other way also. If you take this vector, divide by 2, you are going to get this vector. So this is independent, this is dependent. Anyhow, it is same. One is dependent, one is independent. So the point you need to understand, whenever you have this dependent vector, the space that you are able to span is reducing because it is not helping us in moving in other direction. If it is not helping, we are not able to span a space. So for better understanding, we take one more example. Let's take this example 2, 1, minus 5, minus 1, 2, 8, 3, 4, minus 2. They have provided three vectors. In our previous classes, we discussed that by using three vectors, we are able to span a complete three-dimensional coordinate system. Means we can move on to any point in a three-dimensional coordinate system. But using these three vectors, we are not able to do that. We can span only a plane in a three-dimensional coordinate system. Why? because this is a dependent vector. These two are independent vectors because these two are moving in a two different directions, but this is on the same plane. Why it is? Let's try to understand. Multiply the first vector with 2 and add with the second vector, you are going to get the third vector. Means by applying vector operations, you are going to get the third vector. Previous classes we discussed that using these two vectors, if they are independent vectors, we are able to span a plane in a three-dimensional coordinate system. See, this is a plane in a three-dimensional coordinate system. See, 2, 1, minus 1 is moving in this direction, minus 1, 2, 8 is moving in this direction. Using these two vectors, we are able to span a plane in a three-dimensional coordinate system. But this vector, the third vector, is not helping us in moving in some other direction, because this vector is also in the same plane. Means it is in the same plane. It is not helping us to span the next direction. So that's why using this is a dependent vector, because this vector depends on this 2. By applying some vector operations, you are going to get this. That is what the concept of spanning which we discussed. By using these two vectors, we are able to span any point on this plane. This vector is somewhere around here on this plane. So this is dependent vector and these two are independent vectors. Hope you understand the concept of dependent and independent vectors. If you have any question regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.